Hello everyone, I am Bradley Sward, Associate Professor of Computer Information Systems at the College of DuPage in Glen Ellen, Illinois. And today's video is going to take a look at C++ repetition statements, otherwise known as while loops, for loops, and do-while loops. And there's one more range-based for loop that we can talk about at another time in another chapter. But we're going to hit the main ones today. So as always, I have Visual Studio up and running here on the right-hand side, and I have my PowerPoints up here on the left. And so a lot of little things going on here. So increment and decrement, we've discussed especially when it comes to adding and subtracting one from a value stored in a variable somewhere, that we can do it four different ways. If I have a value f and it's 0 in here, I can say f equals f plus 1. I can say f plus equals 1. I can say plus plus f, and I can say f plus plus. And so that's crazy, right? Like, why do we need all these different ways? And sometimes I say, I don't know, because you can't do these kind of things, I don't believe, in Python. Don't think that just the plus plus, you'd have to do plus equals 1 if you want to do that. But this is the way the language works for us. And so you notice, why would we have two different ways? Why would we have two separate ways to put the plus plus up front or the plus plus on the back? The language, this language isn't called plus plus C. Wouldn't that be even nerdier than what it is already? C plus plus, which is an incremental build from what C is, right? So what is the difference? Why do we care about the prefix versus the postfix version? And the same goes for subtraction. I can just replace the pluses with minuses here, and you can increment and decrement by 1 the same exact way using just pluses and minuses. And so we could show this by just doing some print statements. What happens if I print plus plus f and then a space, and then f plus plus, and then a space, and then end the line, and then just print f. Put an end line, call it a day. So what do you think would print out? Oh, the fun nerdiness of programming here. Let's see, what do we get? It prints out 2, 0, and 2. Of course it does, right? Holy cow, I was not expecting that, actually. Plus plus f, f plus plus. Where is this all coming from, right? Like, where is there the 2? So the plus plus f is an increment. I've never done this, but this is actually new to me too. This is why you don't do these kind of things, because you don't really 100% know what you're going to get. And I apologize to every one of you who has to suffer through AP Computer Science when it seems like so many of the questions ask you all these little details about plus plus this and plus plus that. Like, who cares about these little intricacies of what happens at that nerdy level? Like, what is going on here? But you can imagine I'm incrementing twice, so at least this one makes sense, right? At least that one makes sense because that one should print 2 because I've incremented twice before I get to printing out the value. So the last one is the one that makes sense. And for me, the second one also makes sense. And that's because that is the true difference between prefix and postfix mode here. And so in prefix mode, we increment the variable, then return. So it's like a pre-increment. It happens immediately. And so this happens first. I think I kind of understand, and if I'm not 100% correct, if you know, then maybe correct me once I'm done with this explanation. So I say, okay, this one makes sense. That's a 2. But this one, the pre-increment, you go, well, that should just be 1 then, because it should print 1 since it pre-increments before it prints. But I believe everything goes right to left. No, it can't. It can't go right to left, right? It has to go left to right and then return a. So that's where I'm confused about the first one, actually. Why is it a 2? After 20-something years, right? Like, I can only imagine that it's because it somehow does this one first and then increments this one. I'm at a loss, so I'll have to do some research into this. If anyone knows, of course, let me know. But anyway, the reason why this one why this prints out a 0 is because in postfix mode, the operator returns the value of the current variable, then increments or decrements what's going on there. So what happens is it keeps a copy of the current value, uses that in the line of code, and then when the whole line of code completes, then it increments the variable. So in this case, I would have imagined this would be a 1, and this would be a 0, and then this would be a 2. So I'd say, for me, my mind is blown here. But again, 2 definitely, because we've done 2 increments. This one would be 0 because this keeps track of the value prior to the start of the line of code and increments it at the end of the line of code. So just to come back here, just to come back to this will print 0 and then 1. At this point, do you believe anything I say? Okay, 0 and 1. Because it keeps the value, keeps it stored as a temporary, uses that to print out, it prints out to 0, and then it increments to 1 when the line of code completes. So that's why it comes out as 0 and 1, as opposed to the opposite method, which is ++f, which will print 1 both times. Because it increments prior to the printing, and essentially is just a one-liner inside of assembly language. I am so curious as to why that one printed out 202. But I'll have to move on, got other things to worry about with you guys here. So that's the huge difference, and there are reasons why you would use both, but if you can help it, it's always faster or as fast to use the pre-increment method as it is to use the post. And I'll always remember, I don't remember exactly what year it was, but this was a more advanced course, and a student came in, we had a 5 or 10 minute discussion about this, and everything online tells you that the pre-increment can't be slower than the post-increment because the post-increment is incrementing, but it's also keeping a temporary variable, which means there's more work involved to do the work as opposed to just incrementing what's currently in there. And the student got very, angry, not angry, but it was a very, for computer programming, it was a heated discussion. And then the student never came back to course again and dropped the course. And it was like, of all the things, you're leaving a course over and incrementing of a variable. So just so understand there are differences, so that's why they're here in code. Sometimes you do want to pre-increment, and sometimes you actually do want to post-increment. And so just to say that's what we're going with here. So very simply, just like we've done here, you could see if value is 12, it'll print 12, then increment, then it'll print 14, then print 14. And then over here, it'll subtract a 13, and then it'll print 13, and when the line of code completes, val is set to 12. So all of that is correct as you see it there, and it's just a matter of when the variable gets decremented. And I don't know why it has to be so confusing, but it's just the way it is. That's what this language is all about. Okay, so yeah, don't start getting crazy with this. The one thing you can't do is ++f++. You're like, I'll increment it twice. And you're like, what does it actually say? Expression must be, I don't even know, because it must return a const or something like that. I don't know. But you can't do ++f++. And there's no, it's like, why write code that looks like this? What are you trying to get across? Why are you trying to be so slick and fancy? At the end of the day, your assembly language code looks identical, whether this is one line of codec or 2 or 3. So it is what it is. And so, this is kind of weird, right? Num plus 2, num1 plus num2 plus, you can't do that because that does not have a location in memory. This is just a temporary. I wonder if that's changed since 2011 with the whole moved mechanic, but I haven't. That's another thing I need to go test. Write that down so I can test it out later. So this is something you can see out in the field, like if ++ num is greater than limit, and that means, of course, that the num is incremented in the line of code prior to the test. So the ++ operator goes prior to the testing of the relational operator. So you got to watch out for these things, and a lot of this just comes from just experience and time working with programming. But a lot of this, you don't have to be fancy, and it's like the code speaks for itself when it's an awesome algorithm and it does its job and it's slick and smooth. It doesn't have to have weird little symbols thrown about everywhere just to get the job done a little bit with a little bit less code. Okay, so here, let's get rid of this. Let's talk while loops. Okay, so a loop structure, of course, is a control structure that repeats and repeats and repeats until while a certain condition is true, we will continue to do something, and then when that condition turns into a false statement, then of course we will stop looping. And so this statement should always be a block, just like we've discussed before. Then you don't have to worry about a semicolon. But, just to say, while true, semicolon, right? This is like the one way to just show you your program's going to infinite loop. Because while true, do nothing. And it's just going to come back and come back and come back. That statement can be an empty statement. And this program is sitting there, and it will always sit there doing nothing. It's the tightest loop you can have because you're essentially just running the same one line of code which says to jump back to yourself over and over and over again. And so you don't want something like this, but this is something that you can do. So let's see, while statement true, how about something like this? Int x equals 1 while x is less than or equal to 10. And then I'll print x. And just for the sake of this, and a space, and just for the sake of fun, I'll leave it like that and try to run and see what happens. Those of you already know what's going to happen, but let's take a look. So what happens is, it just prints out 1 for infinity. And we'll get into this in a minute because there are 4 things to account for when you set up any loop structure, whether it's a while loop, for loop, or do while. It's just a matter of how you structure the elements, those 4 elements inside the different structures that matter. And so what I do have to do is increment x before I go about. And then now the program will actually give me 1 through 10 like I'm expecting. So that is your basic while loop there. So let's see. So what happened was, while this statement is true, I will go about and look at these 2 things and do these 2 lines of code. And then instead of like an if statement, when this closing curly brace gets hit and the if statement is done, it falls through and goes down. But with the while loop, it just comes back around. And so when it comes to, like when we teach this to our CIS 1400 students and we're using flowcharting, like when it comes to loops, you already know everything there is to know about this when it comes to a flowchart. It's just a matter of where the arrow goes when you hit that closing curly brace. It really is. Because one more time then, with the if statement, when you hit this, you fall through. But with a while or a for loop, when you hit this, you come back around. The arrow goes either straight down or comes back around. And that's the only difference. We don't have to teach you anything different with flowcharting. We just have to teach you to have your hand go upwards instead of going downwards. That's it, right? That shouldn't be too hard. Most people can do that. Okay, so but again, while this statement is true, go ahead and then keep on going until this statement turns false. So you better bet that your program, like we were saying, shown before, your program better find a way out of this situation, otherwise you're going to have an infinite loop. And it did while x was 1. 1, 1, 1, 1, 1. It never ends, because this never can be false if the value never changes. And so in this case, x is 1, 1 is less than or equal to 10, so it prints the 1, then increments the 1. So 1 becomes 2, and it prints the 2, and the 3, and the 4, and the 5, and the 6, and the 7, and the 8, and the 9, and then it comes back around when it's 10. 10 is less than or equal to 10, so it prints the 10, increments that x value to 11, and then now 11 is not less than or equal to 10, and it falls through and the program ends. So that's what this slide is trying to show you here. If true, keep going. If false, fall out. So to show this one more time, here is the, if this was an if statement, this arrow would go down to here and we'd meet in the middle like we did in the previous lecture. But with the while loop, we do the statements and we come back around. So as long as this is true, it's looping. And as soon as we decide this is no longer true, we fall through. And so they do the same stuff here. They just go from 1 to 5, right? And they use the less correct incrementing style and so forth and so on. And so a little fancier, but not too much more. Int number equals 1, int x equals 1, while number is less than or equal to 5, print something, increment, and then come back around, and then they just actually print something else up. It's all done, just to kind of show it, just like we could probably have done. And the same thing goes, then, yep, we could do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and done. I don't have any new lines for this kind of stuff. Okay, so let's see, will the slide show this? I'm just trying to, let me just find this real, okay, let's just talk about it now. When we find that slide, then we come. So there's 4 things we have to think about when it comes to a loop structure. And so this applies to any loop structure that we talk about pretty much at all. And so you'll see these 4 aspects in all of the loops that we do today in this lecture. And so just understand. So the first thing is I need to maintain some kind of variable or something that starts off in probably most likely a true state, and then over time will transfer into a false state. Like the value of this variable will be a 1, and then over time it will cross some boundary line on the number line where we say, okay, it's like a partition point. It was true over here when it was 1 through 10, and now this thing is turned false when I've moved over to 11 and beyond. And so this incrementing variable is a big deal, or just variable that is allowed to be changed in some way. And so that's part 1, the incrementing variable. Part 2, not necessarily the while part, but is the conditional statement. And so this is basically like your if statement, right? If I just changed while to if, everything would run fine. It just would print 1, and that would be the whole deal. It wouldn't continue on. But this conditional statement resolves down exactly like you do in an if statement, where it all has to resolve down to a Boolean true-false value in which the computer can decide whether to continue the loop or to end the loop. So that's part 2, nothing new there. Part 3 is the code itself, the code that needs to repeat every time it repeats and iterates through this new iteration of the loop. And then part 4 is the one that I neglected, quote unquote. I did it on purpose, but you have to have that variable change every time through the loop so that eventually, some way or another, this conditional statement can cross that threshold from true to false, if it hasn't already done it by not even going into the loop at all. So those are the 4 things. And you'll see when we get to the other data structures, everything's just kind of turned around and changed around, but those 4 things exist in all three loops. Okay, so just again, this is pretty much explaining exactly what I was talking about. While number is less than or equal to 5, test this expression, do this until this becomes a false statement. And it's exactly like what we have going on here. And this is basically a flowchart of their version of it, kind of almost identical to what we have. Ours just goes to 10. Let me change this to 5, and now we're good, right? So if number or x is less than or equal to 5, print something, add 1 to that number, and come back around and keep trying until this is no longer true. I fall through, and then now I'm ready to continue my program. Okay, so we call a while loop a pretest loop. And for exactly this reason, because the testing goes before we actually run any of the code. And so how many times can a while loop run? It actually can run 0 times. And then as we showed, it can run any number of times up to an infinity number of times if you screw up and you accidentally don't have things working right. But sometimes you do want an infinite loop. Our phones, video games, have a game loop that is running at basically as fast as it can nonstop, updating and drawing and doing all sorts of stuff that the game needs to do. And the same with your phone. Your phone is in a loop waiting for events, in event-driven architecture, waiting for you to tap something or waiting for an alarm to go off. There are things that are going on. Your program, your phone isn't just sitting there doing nothing, waiting for you to get it going. All those push notifications, everything your phone is doing, your computer, is doing it as you're sitting there doing nothing. So just kind of keep that in mind. But now we said we ran this an infinity number of times, we ran this a finite number of times, and then if all I have to do is change this to a 6, and it'll print nothing, but done. Because when it gets to the while loop here, the pretest part of this loop, 6 is not less than or equal to 5, so it doesn't do the loop at all. So a while loop, and we'll see also with a for loop, they both are pretest loops. So you can go from 0 all the way up to an infinity number of iterations of the loop. That's just how it goes. And so you have to watch out, make sure that, again, if this is bad, then yep, this is bad. But sometimes, again, it's good to not go into a while loop. And depending on what you're doing, sometimes it matters. So keep that in mind as you go forward. So we already infinite looped because we didn't do part 4 here, right? We didn't increment the variable, especially when this thing is 1. We didn't increment this thing as we went, and there's no way of stopping. There's, unless a cosmic ray comes down and flips something inside your computer and changes the code or the variable sitting inside of your memory, it's going to go forever. And how often will that happen, right? So it's literally called an infinite loop, even though nothing ever runs infinitely. I wonder if there is a computer running. Is that just a piece of, it's just a crappy computer art something? It's running an infinite loop, and it's actually running forever. So whatever, I'm just talking on my podcast. So let's see. And it will repeat infinity until you get tired of it and you turn off the program, because you're just wasting your electricity, you're just wasting your computer power, you're just wasting everything on a program that is doing basically nothing. That's just how it goes. So here again is an infinite loop. We already ran it. All they did was just take what they did before and eliminate the plus plus number. Okay, so now we can go ahead and think about this from the idea of a while loop as well. So like when it comes to input validation. So we looked at input validation in the previous chapter when it came to if statements, and we just showed how we could tell yes or no is a value in a range or outside of a range. And so now we can actually turn that into a way of looping until the user does what we finally does what we tell them to do and enters a number in range. Because before, and the same goes for a lot of students on an exam where I give you something, give me an input validation loop, and you'll give me an if statement, and then maybe you'll give me a second if statement. I'm like, so all I have to do then is put data in wrong 2 times, and I've broken your code. Or even if you put 3 or 4 or 5, all I have to do is just be patient, and then I can break your code. But if there's a while loop here, and everything is running through a loop, and you only let me out of the loop when I listen to you, then you've done your job, and nothing bad can happen. Garbage in, garbage out can't happen. Okay, so input validation is the process of inspecting data, and so and making sure values, at least in this, is valid. And for us, what we're dealing with is ranges. We're going so there are in advanced C++, we can talk about exception handling, and we can do all sorts of stuff to handle if I asked for a number and you gave me a string. Like, we can't handle that right now. No matter what, we can't handle that, but we can definitely handle an integer value being out of range. And so this loop structure, and the while loop is the way to go on this kind of thing. You say, what about a for loop? What about a whatever? The while loop is the way to go on this. The while loop can create input routines that reject the invalid data, give us an error message, and basically force us to continue on until. And this is the pseudo code for this kind of thing. Let me convert that into, let's convert this into some real code here. So let's just say this is a grading exercise, and let's put a value between 0 and 100 in here. So I can say, give me a cout that says enter a value. Okay, and then I can do an int, I'll just use an int value, and then I will see into the value. So we call this the priming read. This is that first line there, read an item of input, and what that is trying to do is basically our priming read before we enter the loop. Because when the user enters data, there's a very good possibility that they listen to us. And so if they listen to us, we don't need to trigger any of the error code. We don't need to go, hey, you screwed up, try again, because it's already done. But if we need to go in there, we can. So that is, those 3 lines of code is the first item here, read. Okay, so you can imagine the while. And so if I want this thing to be between 0 and 100 inclusive, remember how this works out. We have 2 statements we have to do, and we have to AND them together, because we have to make sure that the value is greater than or equal to 0, and also less than or equal to 100 to make this thing work. So coming back, my value has to be greater than or equal to 0, and, I'm doing it the reverse. See, that's the problem with teaching all these courses and all this stuff. I'm teaching this exactly the opposite here. So while value is greater than or equal to 0, I'll just do it. You can see many students make this mistake, and I talked myself into it. When I'm coding for real, I'm not talking to myself too much anyway. And so let's just try it out and see what happens. So while input is invalid, do stuff. So again, remember, I did this wrong already, but let's just continue through. Display an error message. Enter a value between, and I'll use 0 and 100 like this. And then I'll use an exclamation point and an end line. And then, so that is the display, that's the error message display. And then basically all I need to do is steal this guy and just remove this for the value. And just, there we go. And then here is this to read again. So we've done all 4 parts, but again, I haven't done part 2 correctly here. And end while is just a closing curly brace, so we don't have to worry about that. So let's try it out. Enter a value, and I go 54, and then oops, okay, it closes, but were we expecting that, right? Oops. Less than or equal to 100. That's what I was not expecting again. So let's fix this up. I'm usually not this flighty, but there's a lot going on in the world right now. So, okay, so let's try this way. Value greater than or equal to 0, value less than or equal to 100. I said it, I just didn't do it, right? So 54 now goes what? Enter a value between 0 and 100, but I did. 99, 100, 0, 1, what? 555. Well, that works. And that's because I completely reversed my logic. And so with everything else, now everything coming around, and now I'm more correct with my code. And now you can maybe understand this while loop here instead of doing a test here, because this very specifically says while the input is invalid, the word in, or the part there, the prefix is very important, because what I did was I said here, while my input is valid, tell the user they have an error, and then tell me, oops, not again. And that's not good. And so I need to fix this and reverse the logic here, because, and I have to say, if this value is less than 0, or my value is greater than 100, because it can't be both. The number is either going to be invalid on this end of the number line or this end. It can't possibly be in both places at once, so it has to be an or. If you try an and, it'll never work for you, because it can't be in two places at once, and it can't be wrong twice. So you have to watch out for that. And all I did, again, was apply what's called De Morgan's law to basically take the whole statement you saw before and apply not to the whole thing. Just like multiplying an entire equation in algebra by -1 and just flipping everything as you go, it's the same thing. You just flip all the signs, so greater than or equal became less than and equal became greater than, and all the ands become ors and all the ors become ands. And that's all there is to it. And now this will work. I always cross my fingers at this point once I screw up a time or two. I said enter a value 101, enter a value -1, enter a value 0, done. And so the testing of this goes, the fringe cases, right? Making sure that 0 was good, 100 was good. So again, just to show again, if I put a -1 in, these are all integer values, right? Because these are all integer values. So -1 is the closest one, 101 is the closest one, 100 works. And then just to come back one more time, 0 works. So all those borderline edge cases pretty much work. So I can, without more testing, I can, even though you're staring right at it, I can only give you 99.999% guarantee that my code works. There might be some weird little tiny error in there that, especially if there's some weird compiler warning that I ignore or things like that. There might be a little tiny something that still can break through here, but I can give you 5, 6, 7, 8 standard deviations that this code will work for us. And then now we have ourselves an input validation loop. So they have the same kind of thing. Enter a number less than 10. Okay, so enter a number, and so again, you have to think the opposite. And this it gets tricky, because you have to think, in this case, I have to think, because I'm trying to think what would go wrong. Instead of what do I need to do to keep the loop going, I have to think, well, what would I do to get it to stop? I guess, it's like one way or the other, you have to think one way, you have to think negatively. So stopping this loop would mean that I've entered a number that is less than 10. But to keep the loop going, while true, would be I'd have to keep the number greater than or equal to 10, because then that's an error, because the opposite of less than is greater than or equal to. But otherwise, you see it's exactly, except there's only one value to test. We tested on both sides. It only needs to test on one side of this to make this work. Invalid entry, try again. Here's my prime read. Here's the while loop. Here's the error message. And here's the go again. So those 4 parts, as you see, are valid, and you can readily see them in both things here. So prime read, hit the conditional. If I need to, error message and come back. Notice the arrow comes back around in between all of that. And then once you finally put some valid data in, it falls right through. And this is just a more complicated example. If you want to look at that, pause it, and look through all of this, feel free. I am not necessarily going to worry about that this time around. For our previous examples, we've already kind of went through this. And so that variable that we were talking about, the incrementing variable, that we can call a counter. And so when you say, like, I never think of these things with these terms, but just to give it a description, that's a pretty good one. It's a variable that is incremented or decremented every time a loop repeats. And again, we're doing that. It's a loop control variable. It's maintaining, like, this is the thing that's going to tip the scale whether or not this loop continues. And so you can imagine it has to be initialized before you go through the loop. So if I go int value, I don't initialize it, and I say while value is less than or equal to 10 or 19 or 10 or whatever, do stuff, this won't work. And that's, at least on my machine, you get a compiler error that tells you uninitialized data is used. So in a previous video, we talked about the fact that local variables in C++ are not initialized. Global variables are. And so this thing is garbage. It's negative 858 million something. but it's essentially uninitialized data, so nothing good can happen of this, so it's going to make you initialize the value. So yes, it has to be initialized. Make it a 1. So in this case, they're going through and just taking a number from 1 to 10 and then using it to square and do other things. I guess we could do that too. So we could do something like that. Or maybe we could do square root. We could see out and we could say, okay, here's the value. I'm not going to do any fancy formatting. That's kind of beyond the scope of what I'm trying to do. And what if I use square root? And so I can use that value. And of course, right now, this is going to, what's the green squiggly for? But right now, because again, I did this again, I really did do this on purpose this time. It's never going anywhere from it's never going from 1 because I'm never incrementing value. Why is that green? Using uninitialized, no I'm not. Clean and rebuild. There it goes. All right, I cleaned it. Everything seems to be working fine. IntelliSense is a funny thing sometimes. And so here you go. And just to say, like, just to make this look a little, I guess I'll deformat it just to show. I can do a set width of 2 before I do that. And so now everything will print out a little nicer. So everything is now kind of formatted nicer. Everything is right justified. And everything kind of lines up. That 10 threw everything off because it's 2 digits of space. But there you go. There's the value. There's the square root of the value. And, you know, just the same deal. They just do things a little differently. They use tabs and all sorts of different breaks and stuff like that. But there's no reason to worry. Okay, so let's do this a few more times before we move on to the do while. Let me come back. So let's see. So this was how to do things in upgrade, you know, in increments of 1. There's nothing saying you can't increment or decrement by any other value. So what if if I started at 100 while value is greater than or equal to 0, print out the values, and instead of 1, let's just subtract off 10. So what do I get out of that? I get, I'll have to do my set width of 3 now that I'm using 100. But otherwise, what you can see here is that I start with 100, square root is 10, and I can work my way down. Boom, 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 right? So then, and then from down to 0, 0. And so every time I'm iterating through, I'm subtracting off 10. And I'm starting from the top, and from a large number and working my way down, instead of a small number and working my way up. And so I'll just show it because students do it, and this is going to get you points off for sure. Is I see students a lot of times here, they'll do subtract minus value, but then they'll do something like this: if value mod 10 equals 0, do this and then minus value, and you'll get results. You'll get the same end results, but you have done 90 or how much many, like the original loop went 10 times through. This is going 100 times through. So you're doing 90 more iterations of the loop. You're doing 100 total modulus operations when all you had to do was do what I had previously and just subtract 10 off, get rid of the ifs and an if statement on top of it anyway, and get rid of it and just use this like that. And now you're back to where you were, and it iterates 10 times through the loop, and it's done. And so that applies across the board. If I wanted to give me all the values of from 7 all the way up to 49, print out everything plus 7. So there, with the square root, 7, 14 all the way up to 49, and just continues on. And so it just takes practice. It just takes, if I want to loop between specific numbers, just try what you're going to try. And it does get tricky because you're like, well, what if I made like this, less than 50? And you go, again, it'll do exactly what you want it to, but now this is less readable. Because where does the 50 come from? If I'm trying to do, multiples of 7, where does the 50 come from? So this, as much as it is logically correct, it's not correct from a standpoint of understanding what the heck the problem is trying to solve. So when you have a way of going about it, try to make sure that the last iteration is like right on that fringe line of true falseness, instead of going, oh, it's one-off. Those one-off errors for everybody across the board, they'll get you. They'll get you quite often because you're doing a lot of code. You're not thinking about what would happen on that fringe case. Will it be right? Will it be not? And then when you come back later on, you're not going to understand why their 50 was there, or and this is just a simple case. Okay, so that's just wanted to cover that. You don't have to increment or decrement by 1. You can increment or decrement by whatever you so choose. That pretty well covers the normal, plain old, boring while loop. And so now we can talk about its cousin, the do while loop, which is similar but flipped upside down, almost literally here. So the do while loop is what we call a post-test loop. The while loop was a pre-test loop because it did that check up front, right? While true, I'm just saying, while true, if this ended up, or while false, this will never run if this says while false, because I don't even know, would it give me an error or a warning? Because it's like, why even bother if you're going to say while false? Nope, no compiler warning. But you could say, I'm running this 0 times through, because I'm never going to get into the body of the code, ever, ever, ever. But if I change things around, put a do here and put a while, then it's an ugly construct, I'll give you that much. If code can be pretty or ugly, this code is ugly. But even if I put a while false here, because of where the while was put, I will run through and I have to run the code at least 1 time. Big difference between the pre-test loops. And notice in this case, the semicolon is required after the while. And it's confusing, right? Put it up top, you don't need it. Put it at the end, you do, because this is what completes the entire selection structure here, repetition structure. Okay, so run through, test, and if I need to, fall through or come back around. And so, again, it's almost literally flipped upside down, maybe like mirror image when it comes to the way things work. You run the statements first, then you test the expression, and then you see if you need to come around and do it a second time. And so because of this, you can see that the only way to go is to have the statements run at least 1 time before it falls through. And in this case, even with while false, it will run through at least 1 time. And so, okay, so what I can do, I have to put the int x equals 1 up here. So, while, this is the fun part here. Let's just see, while x is less than or equal to 10, oops, do something. Let's print x with a space. And then let's increment x. I'm not going to screw around and play around and forget it again, quote unquote. And you can see here, okay, so it will do exactly like we did before, 1 through 10. You're like, well, this is not, like, when do we use the different types of loops? This is not a good reason to use a do while loop. This is actually a for loop that we should be using, but we haven't gotten to that yet. We're just showing you examples. So again, what's happening is the code's coming in as 1. It's going, okay, do the code, increments it. As long as x is less than or equal to 10, it's going to continue on. So even when it comes down to 10, we go, yep, 10 is less than or equal to 10. So it'll come back around, print it, increment it, and comes back around. So like, how many iterations? Is that actually 11 iterations? Or is that 10? It's just 1, 2, 3, 4, 5. Yeah, I guess, as I say, off by 1 errors. It can trick your brain even if you're pretty well suited for this kind of stuff. But it's the same deal here. X equals 1, print x, while x is less than 0. But what's wrong with this, again, this code, is that x is never modified. So this will actually run 1 time and 1 time only, because it runs prints, and then it goes, well, 1 is not less than 0. So this is false and will fall through. If x was a negative number, it would be an infinite loop, because nothing ever changes. So in these cases, why even have a do while, right? There's no point to it if you're trying to write the code to do this kind of stuff. So they have a do while here for, like, basically, do you want to do this again? Yes or no? Like, taking all the code that you did and just put, I'm not going to put a do while loop inside of a do while loop just yet for you guys. That would be crazy. And so, but you can see I can get an average and then go, hey, do you want to do everything? Do you want to average another student's grades together? Or just average some scores together? Yes or no? And you're allowed to try this. If you do put a Y for yes, no, it comes back around and you get to go on it. Otherwise, it falls through. But again, these are, what do we use a do while loop for? We use them for menu structures or times where we're going to get user input. Because when we know we're going to get user input, we know we're going to get input at least 1 time, right? Because the user has to type something in and hit enter. So it's perfectly good for a do while loop, because then the test comes at the end of the loop. And so continuing on. So again, just to say it another time, the loop executes at least one time, and then it could infinite loop as well. So 0 to infinity for while, 1 to infinity for do while. And it's the same deal. As long as this condition is true, I'm going to keep on going, keep on going, keep on going. And coming back to this idea, we talked about it in a previous lecture or a future lecture, depending on which course you're in. And then talking about menu-driven programs working everything out. So go to that video or go to a textbook or just look up something on the internet if you need to find information about menu-driven systems. And that's it. That's the whole that's the whole idea of the do while. Is it's a while loop flipped upside down, and it's a 5-minute talk. It just it takes a little getting used to because it is what it is. And it looks pretty ugly because like some people are like, what do you do? Do you put the do? Where do you? And it's just ugly looking. It just looks like it's just splotched thrown against the wall and just sliding down all this code. But it's what we've got for that kind of loop. So the final loop we're going to discuss today is a for loop. And so when it comes down to it, everything 99% compatibility between while loops and for loops. And so almost everything you can do with a for loop, you can do with a while loop and vice versa. There's just one tiny little thing that you can't do. And so we've talked about the 4 separate things that you need to worry about when you're using a loop of any kind. And as you've seen, let me maybe go back and pop it in here. Coming back here, the discussion of the do while loop, we talked about those 4 things. The variable that's introduced, the loop changing variable, the code, the incrementing or changing of the loop changing variable, and then the conditional statement. Those are the 4 things. And so whether this was because we made this work for a while loop and we made this work for a do while, and we're going to take those 4 things and just flip them around a little bit and make it work for a for loop. It's the same 4 things. So this is how I would do this for the for loop. I would say for int I equals 1, I is less than or equal to 10 plus plus I. Let the formatting do its job. Cout I and a space. And so all 4 parts that I was just describing to you 15 seconds ago are there, and there's my printout of 1 to 10. Here is the the changing variable. Here's the conditional statement. Here is the incrementing of the changing variable, and here's the code itself. And so it's a little confusing at first, maybe because you have 3 things going on. There's a lot of symbols. And sometimes, when things get pretty complicated, there's nothing saying you can't break everything up onto its own line just so you can see what's going on. Because sometimes this can get, it's not just a simple 1 through 10. Sometimes you have some fancy logic sitting inside of here. But all 3, I like this loop because all 3 of the things are put up front. You can't forget. Like a while loop, you can forget to increment that variable at the end of the while loop. So that's why nowadays I kind of do it up front before I do anything else. It's the first thing I do because I'm prone to forget things, and I'm getting older, and I'm prone to forget more and more things as I'm getting older. So, but it's the same 4 things in different places. And so it's weird because I cannot, because this I variable is scoped to this for loop. So this thing does not exist when I come outside of this for loop. And so that is one of the only rules. It's one of the only true differences between a for loop and a while loop is that with a while loop, I'm setting up my variable outside of the loop, so when I'm done with the loop, I can actually use that variable if I needed to. But in this case, for a for loop, I can't. But if I wanted to, I would take this guy, and this is where for loops get weird. I could go ahead and do this, and this is now equivalent to a while loop, because now I can use I outside of this. So this is equivalent to the while loop from previous. And all of this discussion was before we even get into here. So let's take a look at what the documentation here says. So we showed a minute ago or 10 minutes ago or whatever how to do an infinite while loop. How would I do an infinite for loop? I call this the Metroid operator here. I could do this, or it's a Zoidberg or something like that. But this is, you don't have to, it's weird because you don't have to put any statements in between the semicolons, but you need 2 of them to separate part 1 from part 2 from part 3, right? So this just says for nothing, do nothing. And it's an infinite loop. You will never do anything. It's kind of cool, right? And it looks kind of cool at least. And it's like just completely random stuff that ends up doing nothing for you. But you have the initializations part here. Let me put this back to how we're used to using it. So you use like that. Get rid of this fun little note there. And so you have your initialization, then your conditional test, then your update, then your statement. And so coming back, one thing, there's no semicolon. What will this, see, even with that semicolon, this dies because the I is not part of this loop anymore. So in this case, this semicolon will ruin everything. Isn't that interesting? And like I get that error because I, undefined variable, because I put a semicolon there. And so it was working fine here. I had something else on my brain and I just lost it, and I'm sure I'll come back to it in a minute. Oh yes. So the one thing you have to understand here is kind of the order of operations of the way the four things go. So this part of the for loop only happens at initialization. So this is basically like I had before, where I put it before the for loop. I put it here. It's essentially that. It only happens one time when the loop starts. And then this part happens right afterwards, because that's the conditional statement. And then the code runs. So it goes, this is one and only happens once. Then we do two, part two here, the conditional. Then we do part three, the actual code. And then when we hit this closing curly brace, we increment the variable last. So this is part four. And then we come around to do 2, 3, 4, 2, 3, 4, 2, 3, 4, until we finally reach a point where we jump out of the for loop. So just to understand that this happens once, and this happens anywhere from 0 to an infinite number of times. So just to say, yep, exactly what I was saying here. It's a different way to go about doing things. So again, this is the old C way to do this, but this is what you would do if you wanted to keep count. If I needed that value outside of the for loop, I would define the variable outside of the for loop. So when I come back out and where I hit where the cursor is there, and what would the count value be in this case? The count value would be 6, because while count is less than or equal to 5, I'll do stuff. And so at 5, it's okay. But once I increment and I hit 6, 6 is no longer less than or equal to 5. I'll fall out of the loop, and my count value would be 6 in this case if I wanted to print out what that would be. And in this case too, if I did this, it would be 11 if I fell out and printed I, because 11 is the first number as I'm incrementing up from 1 that is not less than or equal to 10. So again, the four steps in 3 different ways. That's all the differences between the while loop, the for loop, and the do while, pre-test versus post-test. The same 4 things put into different confirmations. Different ways of doing things. But it looks very similar to what we saw in previous flowcharts. And so it starts to make you wonder, why do we have two different constructs, the for loop and the while loop, to do the exact same thing? And so we'll discuss that in a slide coming up here. Why do we need the 2 different constructs? And but you can see that everything else is identical. Initialize, then 2, 3, 4, 2, 3, 4, 2, 3, 4, until you finally fall through to go through, and that's exactly what I was showing here a minute ago. And so they have a for loop to go, and this is the same as what they were showing before about printing out all the numbers and all the numbers squared, and we can do that again just the same exact way. We can print out I, and then we can print out square root of I. We were doing square root instead of square, and then do an end line. And so there we go. There's our values just like before, and we get the same results using a for loop as we did with a while loop. And that's about, but again, coming back again, if I wanted to maybe do all the factors of 10 from 10 to 100, this is where I can put an I plus equals 10 instead of a plus plus I. The one thing I never want to see is what I showed you earlier, is just say if I mod 10 is equal to 0, then print. That's so wasteful, and so it's ridiculous. So this is how again, you'll get the same results, but you will definitely get points off, because that is not the way to go about doing things. The way to go about doing things is just to eliminate this and increment your variable by 10 instead of 1. So there you go. Boom, boom, boom. Okay, so let's see, anything else here? So let's see. Oh yes, so when to use the different loops. Okay, so this is a perfectly good explanation right here. You use a for loop when you have a situation where you want to do a loop, of course, and you know precisely how many times you want to loop. I want to loop 10 times from 1 to 10. or if I had later on we'll have a collection of data like an array or a vector or something, and I want to go through every element and do something with every element in my collection n times. That's exactly as many elements as there are in my collection, so there you go. I want a for loop for this. And so I need an update. Oh my goodness, that's not when I want to use the for loop. That's a different slide then. But you get the point. I want a for loop when I know exactly how many times I'm going to go through and iterate through a collection or the value. I want to go from 1 to 10 or 10 to 20 or 0 to 100 or something like that. And I will use a while loop when I'm not exactly sure, like a collection of data. Is a 7 inside of my array of data? And so I would put code in, like I said, while not found, and I have not reached the end of my collection, check the next value, check the next value. So in this case, it could be the first number. The 7 could be the first element in my array, or I could exhaust the entire search and go through every element and go, nope, no 7 here, and have to say that there was nothing found. And so that's a little more uncertain, and that's when we usually use a while loop. And so where is it here? We'll come back. Oh my goodness. They're deciding what loop to use. Okay, so this is what I thought I was reading a minute ago. Here's my for loop for exact number of iterations. My while loop is more for repeating something until a specific condition exists. And my do while loop, we usually go ahead exactly or at least one time. So something that's like a menu or input where the user is going to input something at least one time. A menu is a version of an input, so it's a perfectly legitimate reason to use a do while. So that's why we have 3 different constructs for this thing. So just to kind of go through couple of these slides, not all of them, just like the while loop, because a for loop is a pretest loop, again, a for loop can do 0 iterations of its shell here. And coming back, if I say I is equal to 11, I is less than or equal to 10 plus I, this will not run anything because this is the first thing that goes. I is 11, but this immediately falls through because 11 is not less than or equal to 10. It's the opposite. It's false. So it falls through and never prints anything. And you can see here it doesn't print anything at all. So just understand then 0 to infinity, just like a while loop. And so this is horrible form. Don't start combining things. Don't go crazy with this. You're not going to win any awards unless you're trying for that. There's a code competition, the most complicated. It's like a Rube Goldberg for code. Like, unless you're trying for that purposely, there's no reason to go crazy and do all this crazy stuff with X's and Y's and increments, and just keep it simple. The whole point of programming is readability and efficiency. Readability is a huge part of programming. The comma operator never seems to work the way you want to. Don't do this. Don't. One day I'm going to go in and erase all this. It's not going to be now since I'm talking about it. And so you can, like we just showed, you can neglect sections of the for loop. And I showed you that. I can make an infinite loop just making it look like Zoidberg there. So just understand that there are things you can do to tinker with this, and that doesn't mean you should. It just means that you can. And so blah, 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 blah. Okay, so something like this. If I want to, okay, let's just do, since I haven't really, too many interesting kind of things. What if I have a sum, and I say, okay, let's just sum up 3 numbers. Okay, so I'll go cout, enter a value, and then I will cin. I'll need an int value, and then I'll cin to that value. And then I'll just do sum plus equals value. I'm just going to do this 3 times over, right? And then when I get out of this thing, I'm going to go, okay, the sum is, and then print out value, or sum, not value, and then an end line. So this is how I would do some kind of looping structure where I go enter a value, and I go 8, and then enter a value, go 9, and then enter a value, 10. And so I should get 27 out of the deal, and I do. Because I'm iterating 3 times through, this loop finally cuts me off, and my sum is maintaining that value of the summation of everything I'm looking for. Just like they're showing here. And they're just going through numbers from basically 1 through 10 and summing them up, and that would get you 55. And so just to say, you can start using this in more complicated ways than what I've been showing you up to this moment. So, yep, keeping a running total. Exactly that, right? I don't know why. It doesn't have to be this complicated, right? And they're using a while loop. So let's change this up. So yes, I can move this over. Let's transform from one to the other. And all you have to do then, is turn, as you're seeing, and those four parts have now been moved around. So I equals 1, while I is less than or equal to 3, do stuff, increment I. Up the sun is. Stupid errors. There we go. I found it. There we go. And then the code will run exactly the same with the while loop instead of the for loop. 9, 10, and 8 gets me 27, like I was expecting. And so, yeah, so just to say, I can do, and the only difference, again, between what we did with the for loop a minute ago and the while loop is I can access I if I wanted to here. The for loop I wouldn't be able to once I kicked out, but I can now because I is scoped at this level, and I would be 4 because that is the value that would kick the while loop out. So just to prove it, just like I say, print out I, put a couple spaces, or space, and say enter value 10, 9, 8, 27, but you say 4 because that's the I value that eliminated me from this, or just removed me from the while loop, kicked me out, so I can continue on. So you can see it gets more complicated, so there's more going on. Is there a number to read? Yes, read it and add it, set the accumulator. You want to make sure you don't put this line of code inside of here, because if I set the accumulator to 0, I'll reset every single time. And then when it comes time to print out the sum, it would just print out the final value that you input, or maybe a 0, depending on how you put your logic into the loop. So you got to watch out for that. So they've got their running total. We've got ours. They're now using now they're using a for loop, and now we're using a while loop. We did this a minute ago, so we don't have to go back and do it again. But you can see, enter 5 values, and then there you go. You've got your 5 values all summed up, and you could do some testing to make sure everything worked out before you blindly trust that your code works like it's supposed to do. Okay, so moving on to what we call sentinel values. I've never heard this term outside of computer programming. I don't know what sentinel. I don't do too much comics and things like that. What does sentinel mean? Was it Sentinels of the Universe or whatever? For being a gaming guy, I don't know much about comics. So, but a sentinel in this case is a value in a list of values that indicates that you're done. Let's just say, like in this case, negative 999, or just any negative value. So if I enter value and then you put a -1, I'm going to infer from that you're done, that you're good to go, and that you don't want to do any more input. So it's used to terminate. So I can kind of do this. I want to enter 3 values instead of 3 values. How about I do something where I'll start with 0 values. I'll start with a 0 sum, and let's just change this up a little bit. Let me steal this guy. Steal this guy here. So I can do my prime read, or should I do a do while? No, I'll just do a priming read. And just say, okay, enter a value. All right, fair enough. And I'll have to tell the user -1 to quit. So I'll put that inside of there so the user knows how to exit my program. And so what I'll do here is I'll say while my value is not equal to -1. I'll do some stuff here. I just have to kind of change this around a little bit because I have my prime read, right? Remember back to our discussion about prime reads and how to do these kind of loop structures. But as long as that value is not -1, I'm going to go in. I'm going to basically increment the sum by the value. I'm going to add 1 to the number of values because there's another. Now let's do averages, right? Maybe I haven't discussed this before. Let's figure out what the average is of all the numbers that you've put in, but you can tell me when you're done. So it's not like 5 numbers or 7 or 10 or 3. You can just keep on going until you're happy, and then I'll average all of them together and it'll be correct. And so I want to make sure I do this right. So then I do this up front because I have a value that I need to change around since it's not a -1. And then I go around and add it to the sum, and then I change and increment the values, and then I try again, enter another value. Let me steal this guy here. And then I try again, and when I enter 7 next time, it comes back around, and then it's not a -1, so it adds it in again. And then when I finally put a -1 here, it will take the value inside. Oh, let me get rid of this int value, because I don't want that to be part of this. I want it to be part of that. C++ is fun like that. And so I get the value, get the value, get the value. I come back around, and then finally when I put a -1 in, I don't do any more work. And when I do things this way, then I don't have to worry about having a -1 value be part of my data. Because if I did this like a do while or something like that, I would get a data value from a user. Then I'd have to check to see if the value is 1. It gets more complicated. But the priming read, as much as it's not the, it's like, isn't there a better way? I'm like, not really. The priming read is probably the best way, because then I don't have to put any if statements into my code to get this to work. So I've got my sum and my average. And so this is just sum divided by values. And as we've discussed before, both of these are ints, so I'll have to use a static cast to make this work. Cast it to double, just so I can get the true number with the fractional component. Here, let me see if I can. There we go. So the average is sum divided by the static cast of values into a double. So what am I going to do? 1 through 6. I should get 2.5 out of the deal if I add this together. -1. And there I go. The sum was 21 for 6 values, and the average is 3.5. And that's what you expect. That's the expected value of a 6-sided die. So they do the exact same stuff. You could tell this person that Mr. Gaddis is a big soccer fan, because how many points did you score today, team? No, it's not. No, let's not even talk about the term pitches and kits and all sorts of stuff, right? So, but anyway, how many points did you score this game, guys? They have a prime read, and as long as you don't put a -1 in, it adds, just like we did. It adds to the total, and then it goes, okay, give me another for a different game. It's a little more complicated, because for them, they actually increment and go, okay, give me a value for game 1, give me a value for game 2, and game 3, so you can see how that fits in here. It's a little, I'm just trying to keep it simple just to keep it going here. But you can see I'll get every time I read and I don't put a -1 in, I'll continue adding just like I did. Just like I did on mine. And then when I fall through, I go, oh, you scored 22 points over 19 games, or whatever it is that it doesn't even call it. He does call them games, a series of games. How about a season? Goodness gracious. Come on, Mr. Gaines. Shame on you. So there you go. 7, 9, 4, 6, 8. This must be indoor soccer, right? Then it's like either that or they're a really good team, right? So, and then a -1 to quit out, because in this case a -1, you can't score -1 points or goals in soccer. So it just sums up 16, 20, 26, 34, prints out my 34. So again, this is a pretty cool way, because the user dictates when they're completed with this. This is not on you just saying, I need 5 numbers. And then it's like, well, I only need 3. Tough. That kind of thing. And another way you could use a Sentinel here is to say up front, go, how many values do you want to tell me? So I guess we can change this up to get, instead of saying, give me a -1, I could start out here and say, let me steal this here for a second here. And say, okay, int values, give me values here. And it's not 0 anymore. Enter how many values to enter. So the user will input that value in for how many they want to do. And so then what I can do now is I have my sum is equal to 0. I have how many values I want to do. And then let's say the off by 1 errors here kind of thing, right? So while, and this is where things get a little more tricky now, because if I do the prime read, let's just try it this way. And if I say while, or just use a for loop here, for int I equals values, I'll just try is I is greater than 0 minus I, because I'm starting from a larger number. I'm not working my way from 0 or 1 up. I'm starting with the value the user told me for how many numbers they want, and I'm working my way back. And so I can steal this guy, so give me a value. There's no longer a need for a -1 to quit, because we know how many times we're going to do this. And so now I could say, well, I'm not going to worry about it. Enter a value. I get my value. So this time around, I'll get it here. And then I'll say, okay, cool. And now I'll add it in, and I'll increment. I don't need to do this anymore. I'm just using this to sum up what's going on. because I need to do this 6 times or 5 times or 4 times or whatever. Just give me a value, I'll pop it in. This for loop will get me out eventually. And then now let's see what happens. Let's try 1, 2, 3, 4, 5, 6 again. Whoops. And was that even the right one? Hold on. How many? Oh, that was, I don't even know what that was a second ago. Sorry. How many values should I enter? 6. Enter a value. 1, 2, 3, 4, 5, and 6. And we're right back to where we were. And so we're using, and so a different way. There's 2 ways to use the Sentinel values, I suppose, right? How do I know how to escape? Tell me how many times you want to loop, or just tell me when you're done. You know, just, it's your choice, unless you're told you must do things in a certain way. But we ended up in the same place. You told me how many numbers. I think the other way is probably better, because what if you just miscounted and you were counting up 27 numbers and you needed 28 or 26 or something, and you screwed up, and now you got to type in all that data a second time because you entered the wrong number up front. You'd be kind of peeved, right? So maybe the other Sentinel value way is better. So when I finally reach the end, I don't have to care. The computer will count for me how many values I input. So I already talked about deciding what loop to use. So now the final idea here is just talking about nested kind of loops, putting loops inside of other loops. Much of the fun of programming is putting these constructs together, putting if statements inside for loops, and for loops inside for loops, and whiles, and all sorts of crazy stuff, because those combinations is, that's how we get these algorithms to solve the problems in the way we need them. And the computer is very happy to nest things together. It can parse all the syntax and do what it needs to do. It's a wonderful, wonderful tool for us. And so nested loops mean exactly that. There's a loop inside of a loop. And so like in this case, if I wanted to print out values, I'd go for row equals 1 to 3, and then inside of here, go for column equals 1 to 3, and then print the multiplication of the values and go, okay, whatever that means, right? And so maybe that's not a good example, but something like this is, where I have an inner loop that takes care of a single student and says, okay, for every tests, who knows how many tests they're going to be going through? And you're going to go, okay, fine, enter a score, enter a score, enter a score, enter a score. And so for that one student, it goes ahead and sums up, just like we're doing here. It's summing everything up for one iteration of this loop, because we go through this 5 times or 6 times, whatever the user wants. And then at the end of the day, it sums up and prints everything out. That's my inner loop. And so now if I wanted to repeat this thing a number of times, that's where I would use now an outer loop to do that and kind of repeat that again, because all of this is pretty much self-contained. Because this works perfectly fine for one iteration of summing up values and giving you the average of them. And that's what we're doing here. We're summing up one student, giving me the results, and then saying, should I do it again? Should I do it again? Should I do it again? How many students versus how many tests? Wouldn't it be easier just to use an Excel worksheet? But whatever, this is a C++ programming course. So my rule of thumb for nested loops is that you do the inner loop first, you get it working, and then a lot of times then once you try to make it work with the outer loop, it's almost trivial, because you'll see it only take a couple seconds. This was a little bit tricky because it took some effort, but putting the other loop in won't be. And so an inner loop goes through all the repetitions first because it's the innermost loop, right? It's the tightest loop. And when we finally fall out, then we hit the bigger ones. We hit the big one, do all the little ones, hit the big one, do all the little ones, and then just keep on going until both loops end up in a false condition, and then we finally fall through all of the for loops, or all of the loop structures. So in this case, the total of number of repetitions is the outer loop, the number of times we went through the outer loop times the number of times we went through the inner loop. So it's a multiplication, not an addition, when it comes to how many times we nested. And so, they don't even describe it. So let's do it. So this is one iteration. Well, how about this? For int, I can't use I anymore, so I'll use j. And say int j equals 1. J is less than or equal to 3. Plus j, do. Yep. And I'm talking about this like crazy, right? We're done. We can now do 3 students. crazy? It's already done. How many values do you want to enter? 2. Give me a 1 and a 2, and then go, okay, cool. And so now, how many values do you want to enter? 3. 1, 2, 3. Okay, fine. Third student, how many do I want? 4. 1, 2, 3, 4. There we go. And the program ends. It's iterated 3 times through. It did everything inside of here, like we did for one current student, and then it finally came back around and tried again for another. And so the final thing we can do to make this a little more professional is just say enter how many students, enter how many students to enter. You get what I'm saying. That English is not the best. But I say, okay, students, give me that, and then C into students. And then working this way down like we did for this one, since we're starting from a high number and working our way down, we can say, okay, I, you're equal to students. As long as you're greater than 0, keep on going in decrement. And now we've done a sentinel value of sorts for both how many students and how many values for each individual student. Because every student could have a different grade. Maybe I'm grading everybody at the same time from all my different courses. I'm just jamming them in. And so now, much better. How many students are there? Okay, there's 4 students. How many values for student 1? 1. Put a 5 in. Fair enough. How many values are there? 2, 5 and a 6, 5 and a half, fine. 3 values, 1, 5, 54, and 12. There you go. And then how many values to enter? And I can put 2 in and say -1. We got rid of that -1, that sentinel value from a long time ago. And so now I average the 0. But it did the 4 times, right? It did everything for me. It did the whole iteration through 4 times. And each time through, I'm the one who dictated how many scores that student needed. So now this program is much more flexible than it ever was before we started using these sentinel values and these dynamically generated loop structures. Not generated, but just dynamic iterative versions of these structures here. So let's see, is that it? Let's not worry about C string, continuing and breaking out of a loop. Okay, so I think this is about it here. So we talked about the break statement when we were talking about the switch statement earlier on in previous lectures. So you can use a break inside of a switch statement. You could use a break inside of a for loop or a while loop. And so you can actually, there's a break and then there's a continue. And this is the last 2 slides here. Last topic, thank goodness, right? And so let me get rid of all this hard work. All that hard work, goodbye. And so what I could do is, and this is not generally good practice, but just to show you, generally speaking, you want to avoid using breaks and continues. I've only used a continue a few times in my life. I've used breaks a lot more, because for switch statements you need breaks, but for loop structures you try to never use breaks inside of there. Okay, so anyway, so what if I did something like this, where for int I equals 1, I is less than or equal to 10, plus I. Make this a little bigger for you guys now. Okay, there we go. And I'll print I, put a space in there. So this is just your typical 1 through 10 loop, right? Just to make sure I'm getting it right off the bat here. So I'm going to print out values from 1 to 10. And so what I can do then is put up front before the print statement, I'll say if I is equal to 7, break. And so what will this do? What will the output be? And in this case, the output will be the values 1 through 6. Because value 1 comes through, it's not 7, falls through, prints 1. It does it for 2 and 3 and 4 and 5 and 6. When it increments for 7, it says, oh, I is 7. Let's break the for loop altogether. It just kicks out of the innermost for loop and then brings me down. And so use it sparingly. And so the interesting thing here, it only breaks you out of one loop, and it's always the innermost loop. So if I had structures, nested structures, and I wanted to break out of more than one loop, I would have to do something more than just use a single break. And it'd be cool if you could say break and then put 2 or something, like how many times you want to break out. But that's not a thing. And you can't just say break, because this is unreachable code. The break will break me out immediately, and it will never get to there anyway. So that immediately breaks me out of the for loop. So there's other ways to go about. There are better practices, best practices to go about doing things this way. This is not one of them. So can do that in comparison to the continue statement. And so the continue just means for this iteration, halt, but I want to continue iterating on forward. So just to show, if I put another thing in here, if I equals 5, continue, what does this do for our code? And now you can see the printout is 1, 2, 3, 4, 6. The 7 is exactly the same. The 7 breaks us out, but in this case, the 5 brings us down to here, but instead of falling through and exiting the for loop altogether, it brings us down to this closing curly brace and then brings us back up to start another iteration. So it doesn't print the 5, but then it increments to 6 and carries on, and the 6 prints out because it's not 5 and it's not 7, and then when I get to 7, I'm done with the break. And so these, so we say all of that stuff when it came to the switch thing, switch and break and continue and default and all that, and switch and case, whatever, all those things. There's a lot of keywords going on there. They all have a purpose. They all have a reason. And so this is, those, like, a lot of this is, I can't right now figure out a better way to do this to get out of a loop. So for the time being, I'll put a break in, and hopefully I'll be a little more professional about it when I think it out or I come back a little bit. And now that it's working, I'll refactor my code so I'm not using continues, I'm not using breaks in my code. Because for this, what would I do? Like I said, like this is where it gets, there's a balance. There's a balance between writing more code to, versus, because the more code I write, the more complicated it is to read and to maintain. And this is pretty clear. If I is 7, I am done with this loop. But what if I wrote this like this? I say, okay, bool done equals false. And if I is equal to 7, okay, so if I is equal to 7, done is equal to true. But then it's not going to, so let's just get rid, let's leave the continue in. This is just for the break itself. But then I'd have to put an else here, because if it's 7, I don't want to print it, because it's supposed to immediately kick me out. So otherwise, print it if it's not 7. And then when I come up here, I can say while I is less than or equal to 10, and done is not equal, or done is equal to false. Do. And so I can have a conditional, a subconditional, 2 things inside of here. It's already getting complicated, but this is exactly, gets me to the exact same place. Excuse me. So 1, 2, 3, 4, 5, 6, 7 sets this done flag to true and doesn't print, and then comes around and exits out because done is not equal to false, done is equal to true. And so you're like, it gets me to the same place, and it avoids using the break, but it's made it so much more complicated. So there's a balance. So it's like I said, there are a lot of teachers I've heard from some of you students already, they're like very strict standards from your instructors. And I go, everything is malleable. There's reasons why sometimes we break the rules. And maybe this is one of those times where we say a break is easier than the alternative. And that's just the way it goes. And that goes across the board when programming comes around. Like, as long as you have a pretty good reason for why you do things differently, then the standard, you can generally get away with it. If you're doing it just because you have to be special, and you're like, I can do this really cool. I was the same way back 20 years ago. I would write my code like, how come nobody understands my code? It was, I had some pretty individualized syntax and formatting. But again, not going to help you in the long run when you're working with other people, or even yourself coming back. What is this trying to do? This is pretty complicated stuff. So anyway, that is it. My soapbox. I can finally go have dinner, go do something else. No, I'm just kidding. Can go take some more, just like you guys. You're done with the video, you can go relax and come back later and get going on understanding more topics. So let's see. Next topic depends on where you are. You're going to be taking care of functions or arrays. Either way, arrays are coming up in your future, so get ready for them. They're coming. They're fun. But as always, swardb@cod.edu is a way to get a hold of me through my email, or you can send a comment here on YouTube if I misspoke. Because again, I do this, it's an hour at a time, right? And it's hard to talk for an hour and not slip up. I feel like Yanni at the Acropolis here with my keyboard, my mouse, 2 monitors, things going on outside, my kids running around. So, and I can hear all these things. So sometimes, yeah, you can say the wrong thing or click the wrong place, and I don't mind showing you my mistakes because I'm a programmer. Everyone makes mistakes, but the ability to fix them in a quick manner is a big deal as a programmer. And just to say, oh, I have nothing wrong with my code. My code is always perfect. My code is always formatted. No, that's not true. So just want to show you guys that no matter who you are, no matter how long you've been doing this, there's always room for improvement, room to move forward. So thanks again, everybody. We'll see you in the next videos. Have a good day.